This is the first video in our last lesson on trigonometry, and it's appropriately titled Too Many Formulas because there's a bunch of them. Notice our objective here is to use all of these formulas to find exact trig values, rewrite formulas, solve equations, and verify identities. And when you're doing this enormous assignment, of course you just get to pick some of the problems between 1 and 110. Just make sure that you're getting practice with as many of these formulas as you can. Try to fulfill all of these objectives that you're trying to do all of these different things. Yes, there are too many formulas here. There's at least 19 depending on how you count. You could also count 21 formulas. By anybody's count, it's probably too many. So again, when you're doing your assignment, make sure you try to get practice using as many of those as possible. When you're using them, when we see them in this lesson, try to look for patterns. How those things look help you try to remember those things. Maybe even if you understand how they're derived, that might also help you to remember them. Whenever you take the test over all of these sections, you get to use a note card. You get to make up your own note card with all of these formulas on it. Or you can take the option of not using the note card and getting a bonus of 10 points. It's your choice. So just realize this. We're going to have tons of formulas. Most of these formulas, you're not going to get an extensive workout on these things until you take calculus, with the exception being, of course, on your quizzes and your tests. In calculus, you use these formulas to help you simplify expressions, some trig expressions, some trig functions, before you integrate it. That's 1/2 of calculus. So let's look at our first set of formulas. These are double angle formulas. Double angle because you can see here I got sine 2u, cosine 2u, and tan 2u. So for sine, it's just simply sine 2u is equal to 2 sine u cosine u. For cosine, we've got all three of these. And depending on the problem, we might use one, the first one, the second one, and the third one. Cosine squared u minus sine squared u, 2 cosine u minus 1, or 1 minus 2 sine squared u. Tangent, just like sine, only has 1. It's equal to 2 sine u over 1 minus tan squared u. Over here on the right, you can see that these things are pretty easy to prove if you just use the sum formulas from the last lesson, and the fact that 2u is equal to u plus u. So here's our two angles that we would sum up with those formulas and then simplify it down to get these. Let's try to prove this first one. Sine 2u is equal to 2 sine u cosine u. So when you prove these, verifying an identity, you start with one of the sides. Here we're going to start with sine 2u. And then I have to show it looks exactly like this. So 2u is the same thing as u plus u. So I'm just going to substitute that in. So sine u plus u. So remember that what the formula is for the sum of angles and for sine is sine u plus v is equal to sine u cosine u, same sign plus, and now switch them. Whoops, that was supposed to be a v. Cosine u sine v. That's what we're going to do right here. So this should be equal to sine u times cosine of the second angle, which just happens to be also u, plus cosine u times sine u. So notice that this left side right here is exactly the same as this side if I just rearrange those terms, which gives me 2 sine u times cosine u. Now I can see that it's been proven.